super excited that we've got Starboard and Ollie here to talk a little bit more about how they're navigating sustainability in the world of equipment design. A little bit about how this relates to world sailing and our sustainability agenda 2030. So targets 7 and 8 is essentially a key around here. So we're working with industries to promote new products that with lower environmental impact for sailors to access across the world, and also collaborating with the marine industry to promote more sustainable equipment within the sport as well. So I'll hand over to Ollie, who will take you through this. Just a bit of house rules. If you guys have any questions, feel free to drop them in the chat. We've got some people monitoring it, and we can interrupt and just let us know.
Okay, I'm just going to share my screen. Let me know if you can see that, Rebecca.
Yeah, that's good.
Perfect. Okay, well, welcome everyone. Thank you very much for joining. This session's on navigating sustainability in the world of equipment design. My name is Ollie Bignell, and I'm the Materials R&D Manager for Starboard. So Starboard is a world-leading water sports equipment manufacturer focused on sustainability. We've got award-winning designs across stand-up paddleboarding, wing foiling, and windsurfing, and we are the owner and operator of the Olympic IQ foil windsurfing class, which was selected by World Sailing for use at the 2024 Paris and 2028 LA Olympic Games. Now, for those of you that have never seen IQ foil class in action, it's a really impressive design, unlocking the world of foiling to Olympic windsurfing, and allows flight in as little as 5 knots of wind, with athletes reaching up to speeds of 40+ knots in higher winds. Now, the IQ foil class is very different to any other, especially in its approach to sustainability. Now, first, we measure the carbon footprint of our boards to understand their environmental impact caused from their production. Our latest estimates put that at around 152 kilos of CO2 equivalent for every 11.2 kilo board we produce. Then we work with our partners, Worldview International Foundation, to turn negatives into positives, planting VCS certified trees in Myanmar to offset that impact to 10 times over. This roughly equates to 22 mangrove trees for every IQ foil board sold. And we also calculate the emissions from all competitors and officials' travel, as well as any motorized vehicles which we use at the IQ foil events to offset these 10 times over 2. We call this 10 times climate positive. But we don't stop there. We also understand the impact of the plastic materials used in our boards and their contribution to the global plastic pollution problem. Whilst we've shipped all of our boards in plastic-free packaging since 2017, we also work to collect each plastic in Thailand and Myanmar equal to the weight of each IQ foil board sold, supporting local communities and cleaning beaches. Now, all of these projects are excellent ways of creating positive impacts on the people and planet around us. However, we look at our overall impact like a bathtub. We turn on the tap, it fills up with water until it overflows. If we pull out the plug, we can stop the water from overflowing, which is a great solution to avoid catastrophe. And that's what we relate our positive impact work to doing. But we also need to turn off the tap at the source to stop the problem. And that's what I'm going to be talking about today. Starboard is doing an absolute ton to create positive impact from its activities, but in parallel, we're also working hard to reduce the impact from our products in the first place. Now, when we look at the easiest measurement of environmental impact, which is our carbon footprint, for our IQ foil board, for example, we can see that almost exactly half of that comes from the materials that we use in the board's construction. And that's exactly what my role focuses on. In keeping with the goals of sustainability for the class and for the sport, we've used the IQ foil and its committed shape as a platform to experiment and innovate in sustainable design and materials. Today, I'm going to talk a little bit about our latest concept boards, our process, progress, and our plans for the future. Now, our journey began with carbon footprinting. That's something we already did to ensure our 10 times climate positive claims for the IQ foil events. But in this project, we completely overhauled our process and onboarded Marine Shift 360, which is a tool to help simplify the lifecycle analysis process for us. And I think you've heard about them in previous World Sailing Sustainability sessions. Now, if you missed that session, don't worry, I've got you covered. What is a lifecycle assessment, or LCA? Now, it's a methodology or tool used to assess the environmental impacts of a product, process, or service throughout its entire life cycle, from raw material extraction all the way to disposal or recycling. A carbon footprint, as we did previously, is generally a key part of an LCA. But overall, an LCA considers a much broader range of environmental impacts and examines the entire life cycle of a product or a service. So why do we start with an LCA for our products? Well, this analysis allows us to see the board in a different way. Just in the same way that our product team have programs and tools to analyze the shape of the board and look for areas for improvement, we use this tool to identify environmental impact hotspots and compare the impact of using alternatives. From this point, we're able to inform decision-making from the design stage and really integrate these considerations into the design process. Lastly, this gives us a constant scientific basis for our claims, especially on their environmental performance, as well as measuring our own progress in making those improvements. Now, for our LCA, we use Marine Shift 360. I think I can see Ollie Taylor in the chat there. He is from the Marine Shift 360 team. We work closely with him, and it's a tool designed by 11th Hour Racing and Anthesis to help boat builders specifically and sports equipment manufacturers easily understand the impact of their production. I know it's already used by the Ineos Britannia GB Sail GB team for their boats and how they announce this. And we use it for all of our boards to understand, reduce, and offset their impact. It has an easy to use interface like this, and we absolutely love it. Now, one of the benefits I mentioned earlier from using a lifecycle analysis tool instead of a carbon footprint is there's a much broader scope of impact from metrics that we are able to assess. With Marine Shift 360, there are 5 key areas covered in our assessments, and they are all considerations for us when we're trying to design for a lower impact. I'll run through them just quickly for you. So first up, we have global warming potential, and that's very similar to a carbon footprint. This measures the amount of heat trapped in the Earth's atmosphere by greenhouse gases, usually over a 100-year period. And this amount varies based on the type of gas released. For example, methane is far more potent than carbon dioxide, and therefore we have to equivalent it and measure it in kilograms of carbon dioxide equivalents. The second factor we consider is mineral resource scarcity. And this assesses the depletion of non-renewable, finite and scarce resources like metals and minerals. And it's a really great indicator to understand sustainability of a material's feedstock. This analysis considers extraction rate and yield, the reserves available globally, as well as the environmental impacts of the mining activities themselves. Now, in order to equivalent this between different materials, we measure it in kilograms of copper equivalents. Thirdly, we have water consumption. And this assesses the amount of water used at various stages of production, including raw material extraction, processing, cleaning, and considers not just the quantity of water, but also its potential impact on local water sources around it as a result of those uses. We measure this in litres, very simply. Energy consumption. This is another factor we consider, and it assesses the amount of energy used or consumed during the production of whatever it is you're producing, including electricity, fossil fuels, and renewable sources. It evaluates the energy efficiency and the environmental impact of that energy generation, and we measure this in megajoules. Lastly, we consider marine eutrophication. which is the nutrient enrichment of aquatic ecosystems. It's a huge problem in waterway pollution and leads to algal blooms, oxygen depletion, and overall ecosystem collapse, where flora and fauna in these ecosystems are not able to get enough oxygen due to overstimulation of the algae in these waterways. So broadly it evaluates the release of nutrients such as nitrogen and phosphorus in manufacturing activities. Really important point to consider. And we measure this in kilograms of nitrogen equivalent. So that wraps up our environmental considerations and metrics that we gained from our life cycle analysis. But we also have to, as a business, consider some other factors as well. Now, firstly, we need to consider durability. We have to consider that our customers are going to receive quality products that last as long as possible. Something can be as sustainable or as environmentally friendly as possible, but if it doesn't last a long time, you end up with what I call the paper straw fallacy. You use the straw and it falls apart straight away and everyone thinks it's terrible. Secondly, in order to be competitive, as well as to have high performance equipment, we need to make sure that our boards are light. Customers are less likely to buy into environmental performance if it means that their experience on the water is less fun. We also have to make sure that we are financially sustainable as well. And so cost is always a consideration. We need to, when looking at environmental design, keep our costs as similar as possible to ensure that the price stays the same for the customer. A huge increase in price is not going to lead to a happy customer. We also need to ensure that we can scale our production, and workability is really important for us to make sure that we're able to manufacture products at scale. We don't want to make one sustainable board, we want to make 1,000. And so we have to make sure that the materials and processes that we consider in design are realistically possible for this to happen at scale. And lastly, we have to look at the commercial availability of what we're using. There's an absolute ton of sustainability or environmental focused materials or processes out there, and they all claim all sorts of awesome benefits. But we need to make sure that they're actually available on the market out of the lab phase and at an industrial scale, so that when we are producing these boards, we don't run into any supply issues along the way. Now, so looking at sustainable board design and navigating sustainability in this area, normally we would follow what was done before and use the same materials and same processes, and then consider the environmental impact after. And that's where a lot of people are at with their environmental considerations. Only making small adjustments where they can after the fact. But this time, onboarding a new system to analyze the impact and make decisions from the design phase, we're able to think about environmental impact from the ground up, taking into consideration all of the metrics we just discussed. And our recent R&D journey have had 3 key goals to improvement. The first is reducing our carbon footprint. In line with the Paris Agreement, we need to lower our CO2 emissions in order to hit our targets for net zero. Second, we want to improve the recyclability and end-of-life solutions for our boards. Landfills are filling up. Many EU companies are limiting what is allowed to go into landfill, especially in fiberglass-based and composite materials. And so we have to consider how we can better find better solutions for the end of life of these boards when they do break or are out of date. And finally, we want to lower the toxicity of the materials that we use. Many materials used in composite board and boat design are very toxic for people and for the planet, and that's something that we want to mitigate. So that concludes the overview of our process and how we approach design and how we got to this point. Now I'm going to talk a bit about the progress that we've made along the way. So when we set out to lower our carbon dioxide emissions, we broke down the emissions of each board by material. And for the IQ foil, for example, we found that over 40% of our raw material emissions come from carbon fiber alone. Therefore, hitting our first target, the goal was clear. We need to reduce our reliance on carbon fiber and find a lower CO2 alternative. We use this material a lot in our high performance boards, because it's very lightweight and high strength, but it's something we need to balance with environmental performance. So carbon fiber, it's often regarded as a material at the heart of performance and makes up a significant chunk of an IQ4 board's emissions due to its high environmental impact across all of our metrics you can see there. In almost every metric, it has a significantly higher impact than almost any other material we use, literally being off the charts in some of the analysis that we've done with other materials. And to look specifically why the global warming potential value for this is so high, the carbon dioxide value is so high, we have to look at the processing required to be able to manufacture such a high performance synthetic material. It takes at least 9 key steps or processes in order to take carbon fiber from its raw material, which originates from natural gas and crude oil, to its final form, able to be used in one of our boards. Each uses specialized energy intensive machinery and requiring transport to each facility along each step, all adding to the global warming potential of the material. Now, when we researched this, we realized that there was a common factor between highly processed synthetic materials and high global warming potential. And so when we were looking for alternatives, we set out to find a material that required far less processing. And after a significant amount of research and trials with different materials, we landed on basalt fiber. Now, basalt fiber is a natural mineral fiber derived from basalt rock. In our lab tests, we found that it can just about keep up with carbon fiber in a lot of our applications. But it has, as you can see, significantly less processing steps, which ultimately leads to a 98% decrease in the global warming potential or carbon emissions for every kilogram of basalt fiber that we used compared to carbon fiber, which is absolutely astounding. On top of that, it's also incredibly easy to handle and as a naturally occurring material, not very toxic to humans, as it's not synthetic, which is another great benefit. So our second target was improving the recyclability and end-of-life solutions for our boards. Now, when we put our boards together, all of our materials are bound together by a resin system or an epoxy system. And this is a strong thermoset matrix to make sure that we get the most performance out of our material. But as a result, once we combine all the materials together, it's incredibly difficult for us to break them apart. And this is one of the largest limiters for us in terms of recycling in composites. And it means that any old broken boards are forced to be sent to landfill, which is, in our eyes, a fairly unsustainable solution. Therefore, we knew that we need to work on the resin systems that we were using and try and identify some more recyclable resin systems that we can use. Now, we made a ton of progress at the start, working with a few different recyclable resin system providers like Recyclamine, Melinda, and Swancore, and we're able to test the ability for us to recycle some of the composite materials that we use in our boards with their solutions. As you can see here, we were able to take on the left a thermoset composite laminate, remove the resin system with their process, and recover some of the original fiber. Now, the problem with this is that a lot of these aren't at a stage where they're commercially viable for us and many others to really use at a production scale. The costs are quite high, and the only way that we would be able to utilize these solutions is to have a ton of custom machinery to be able to process our products, our boards at the end of life, and split those materials into their different streams, which isn't realistic given the second barrier to recyclability, which is logistics. We, as Starboards, distribute to over 90 countries worldwide. And so investing in a solution to be able to process all of these boards and manage the materials at end of life is a real concern, because logistics mean that we would have to ship that equipment in order to process it, break it down, and all of that can mitigate or even outweigh the benefits of recycling it anyway, let alone the cost increase on our side. And that's why for now, we are not aiming to create a perfect closed loop system. It's not realistic for us right now. But instead, we realigned our target here to try and improve the recyclability of our boards using existing processes to make them more realistically viable at the moment. One of these processes that we looked at is managed by Composite Recycling. They're a company based in Switzerland that can melt down old broken composite parts and extract many of the fibers for reuse, similar to the other systems, but using a very low energy intense method that is able to move from place to place. We've been working with them for a while. They're developing a containerized solution that we could move to event or project sites. And we provided a bunch of old broken boards to them to test. But we came across quite a significant barrier to recycling these boards every time. One of our biggest issues with recyclability in this sense is PVC foam. Many of the processes that try to break down our boards, including that used by Composite Recycling, results in the release of chlorine and many other nasty gases from the foam, which are very dangerous to humans and animals. Now, we use PVC foam in many of our boards to make them super strong and durable, which means that we can't recycle any of the other materials without removing that PVC first and then processing it, which is extremely costly and can sometimes outweigh the benefit of recycling those materials in the first place. Additionally, PVC has a host of forever chemicals, or PFAs, in it. They are both in it where it breaks down, as well as produced from their manufacturer. I won't get into PFAs and forever chemicals right now, as it's a whole different topic on its own, but the bottom line was removing PVC foam was a high priority for us to improve the recyclability of our boards, as well as bring a host of other environmental benefits. So when researching alternatives to PVC foam, a lot of the time we were seeing PET foam as an alternative. And you may recognize the name PET as the material used in plastic bottles. Now, we had used PET foam in the past, but with not much luck. We knew it worked, but we didn't want to replace PVC with another virgin plastic option that didn't perform as well. So that's where we started looking at recycled PET options. And the solution we found uses recycled PET flakes from plastic drinks bottles. Up to from 45 to 100% of the material is recycled content from plastic bottles, significantly reducing the mineral resource scarcity impact by over 20% compared to PVC, given it's using a recycled feedstock. Now, due to the processing required in this recycling, it also has a higher impact on marine eutrophication compared to our incumbent PVC foam, which is a negative, but we see overall that this process is a balancing act. And we believe that overall this change has more positive impact than negative. The only other major downside to using this material is that it has slightly lower strength compared to PVC foam, which brings us to the discussion on replacements with alternatives. Now, in some areas during this process, we could be easily deterred by the difficulty in trying to replace a high performance, high environmental impact material with a lower impact option that does not perform as well. Now, recycled PET is not going to be as performant as a virgin PET foam. Even virgin PET won't keep up. And that's something that the product team were reminding me time and time again. And that would be an issue if we were just looking at replacing these materials one for one. But in this process, we're not trying to replace. We are instead trying to design around these differences and use other materials to their strengths. For example, where we knew that some of the shearing strength of recycled PET may fall short of the durability that we need and we expect for our boards, we decided to add some extra reinforcement in key stress areas to make up for that. However, it's not all plain sailing. It's a difficult design process. And in some cases, we do start to see some compromise here on weight in order to achieve our targets as we're using materials that at current simply can't compete with their higher impact alternatives on a performance basis. So lastly, in our targets, we come to lowering toxicity, which is something that we've already made progress with, switching basalt fiber out for a lot of our carbon. And this is really important for the health and well-being of our workers. You can see in the workshop, the guys have to wear a ton of PPE. A lot of that is because of the materials we use and the toxicity of being around them for a long time. Now, one of these key materials we use is fiberglass. And we use a ton of this in our production because it's a really cost-effective material used across the marine industry to help make lightweight, rigid structures. However, this is, much like carbon fiber, a synthetic material that uses finite resources, as previously mentioned. It's also highly toxic to humans and the environment. Anyone who's worked with fiberglass knows how irritating it is, especially if it comes into contact with any uncovered skin. All of our teams and anyone that works with fiberglass is generally fully covered in PPE, wearing gloves, because otherwise it can cause rashes and irritation and all sorts of other health issues. And that's why we wanted to minimize our use of fiberglass where possible. One of the ways that we can do this is actually by using wood, the oldest board building material in the world. Originally, surfboards were made from wood, and so it felt really good to move back to a material like it. We specifically use FSC certified pine wood, which is derived from sustainably managed forests, where trees are chopped down and harvested in a way that promotes forest regeneration and conservation of biodiversity. Now, this material, swapping it out for fiberglass, means that it actually has a negative global warming potential value, or carbon footprint, due to the carbon dioxide absorbed by trees during growth. It's completely bio-based, which means it's a renewable resource and breaks down naturally in the environment at end of life. At times, it can be difficult to work with, given it's a very thin veneer material, and natural growth can cause inconsistencies. Additionally, transportation is a consideration for us, given that our wood is generally grown in Australia. However, we believe that the change is hugely beneficial to the overall toxicity of our boards, which is what we're trying to achieve here, and reduces a significant amount of the glass fiber that we would otherwise use in construction. So, putting it all together, whilst we made some great strides with these breakthroughs in the lab, we still needed to be able to put all of it together in a board and test how these materials work in a real life situation. We normally assemble all of these materials to make our boards around an EPS foam core, which is actually our most used material by volume and weight. Our EPS foam is a really high performance version of polystyrene packaging that you would see in consumer goods. It's a great material to keep our boards buoyant and lightweight, but when it breaks down in the environment, it creates a ton of microplastics over hundreds of years, which is something our beach plastic collection teams understand very well. Now, whilst EPS foam is technically recyclable, doing so from end-of-life windsurf boards, scraps, is generally not profitable due to the processing required, and therefore in practice it's not really done. Now, we looked at a ton of alternative foams that we could use that are less toxic to the environment and had better end-of-life solutions, but at the end of the day, none of them were really able to achieve the low density that EPS can. And so we weren't able to implement them without expecting significant weight increases. We also tried working with some already recycled EPS foam to prove that that process could work, but this would have added a whole kilogram of extra weight to the board alone due to the increased density from the core. And that's a significant weight increase for one component of what's only an 11 kilogram board. We did a ton of research on some really innovative solutions, looking at 3D printed honeycomb style core designs using recyclable PLA filament. And that's a really easily recyclable material, requires not a lot of processing, And we found that with the 3D printed designs, it unlocks some really interesting design pathways that we'd love to look at in the future. But the process at the moment isn't scalable in a way that makes commercial sense for us. And finally, we sat down and thought, well, why don't we just remove the core altogether? A process that Starboard already does for some of our high performance racing stand-up paddleboards, using a hollow core construction rather than using a plastic core. When we remove the core, we also remove its impact. However, looking at this design change overall and when we were able to assess the overall impact using Marine Shift 360, we had to completely reimagine the construction of the board and relied a lot more heavily on carbon fiber and other high impact materials. So ultimately we found it wasn't a viable solution, because the emissions reduction that we calculated from this change were actually not as high as we were aiming for. So in the end, we found a new solution. For this board, we decided to use a plant-based bioadditive for our EPS foam. We mixed this in with the polystyrene beads before we expand the foam to create our core. And we do this in a way that allows the EPS to biodegrade in a landfill setting without resulting in the production of microplastics. To make matters better, this breakdown is able to occur over a matter of 5 or 6 years, not hundreds of years, which is a far more sustainable solution. The other benefit is that this results in almost no structural performance change or weight increase, whilst it significantly improves the end-of-life solutions for the board. Now, the only problem with this solution is that due to the processing required to mix in this solution, we're not yet able to implement this at scale. Otherwise, we would be rolling this out as soon as possible to all of our production boards. However, based on the challenges, we think we're able to overcome them in the near future. And so we were happy to proceed with using this material in this project, and we will continue to in the future. So the result of all of this work was a new board. We call it the EQ foil, as you can see just behind me. And this is exactly the same shape as the IQ foil board, but is a concept bringing together all of the development we did on alternative materials, showing off its FSC pine wood cover on top. Through the changes we mentioned today, as well as a few more that I haven't mentioned, resulted overall in an 18% reduction in the global warming potential in the board's life cycle analysis, which doesn't sound like much off the bat, but when we focus in on just the raw materials emissions, which is what we've been focusing on today, we see a much greater decrease of 37% reduced global warming potential. Now, even within this scope, when we look at the areas that we've focused on today, where we can see a 75% reduction in the global warming potential. Now, that doesn't include a lot of the other areas of raw materials where we are yet to make significant strides, but we hope that we can make similar progress in those areas too. What we want to show here is that we've focused on some specific areas, and in those areas, we've made a really big impact. Now, looking at all of the other metrics across our boards, we see that we've decreased every single metric for environmental impact across all 5. So in global warming potential, as I mentioned, it's just under 19% decrease. Our mineral resource scarcity metric has been reduced by 14%, water consumption reduced by 10%, energy consumption reduced by 23%, and lastly, marine eutrophication reduced by a third. Now, additionally, with this project, we see it as a success. We were able to hit all 3 of our key targets in some way. We lowered CO2 emissions, we improved the recyclability of our boards, as well as making some great strides in our work with other systems for the future. And we lowered the toxicity of the materials in the board, both for humans and for the environment. However, these improvements did not come without some drawbacks. The final board that we have behind me is around 500 grams heavier than a reference IQ foil board, which is around 4% increase, which is pretty significant for a racing board, especially when we consider that it's a one design class and everyone's trying to use the same equipment. And lastly, we're still unknown on the durability on the board. We're still testing this board at the moment and receiving feedback for the feel from the rider, which is something intangible that's hard for us to design for at the start of this process. But as we gain more feedback on the materials and how they feel, we'll be able to iterate and find some better solutions. So lastly, I'd like to speak a little about our plans for the future. So Paris 2024 Olympics coming up in just under 6 weeks. We'll start to see the IQ4 class in action. The team and I at Starboard will be in Marseille for the Olympic windsurfing and showing off this board and displaying the work that we've done to the industry to show what can be done when we focus in on sustainability in equipment design. If you're around, if you're in Marseille, please do come and see us, come and chat to us. We'd love to tell you all about the board and the improvements we've made, and love to hear your feedback as well on what you think about the improvements that we've made. Regarding our plans for the future in our development, today we've only really been looking at raw materials because it was the largest area of our emissions. But there's still a whole other 50% or half where improvements can be made to further help reduce this impact. And that's where we're going to start to be looking at other areas of improvement. For example, in energy. Energy use in our manufacturing process is roughly 30% of the emissions from the board. Now, this already accounts for 30% of our electricity use in our manufacturing comes from solar sources. But by the end of 2024, we expect that our solar usage is going to increase to just under 50%, which alone will provide an additional 22 kilograms of carbon dioxide equivalent of emission saving, which is another 14%, which is significant. But making small impacts in all of these areas overall, we think will create a much larger impact. So, conclusions. We've seen that material design choice can significantly reduce the impact of our boards and the sustainability of our products. But there are still lots of other areas that we need to focus on to make improvements in. Using impact measurement tools with simple metrics like we have helped us understand the impact from the design phase and help us iterate from a ground up perspective. The industry is moving incredibly fast, and at the start of this project, we would have loved to have some of the materials that are available now that weren't around back then. There are always things popping up that people are sending me going, you should use this, you should try that. I'm incredibly jealous that we weren't able to use them from the start of this process. But we'll continue to do so and to include them in our development. It's an iterative process, really. Lastly, if you're interested in navigating sustainability when equipment design, or if you're working with a class, an industry, a boat builder, how do you get started? Well, first off, what we did was we started measuring. Understand your carbon footprint. Start with carbon footprint. That's what we did. We've been doing it for a while, and it's only from there that we are really able to start pushing and making strides to be able to reduce this impact. But before we did any of it, we were just measuring and understanding where this impact came from. Carbon footprinting offers a great metric to start, as it's an easy way to measure against others, as well as easily track your own progress as you make improvements. Other factors that we've considered today, like mineral resource scarcity and end-of-life solutions, can be a little bit harder to track or to design for because they're a little bit more complicated. Now, once you do start doing this, you'll likely find some easy wins when you understand your impact, in the same way that we understood there were some easy wins in trying to reduce our carbon fiber dependency in order to have a huge impact. You'll learn a lot about the design choices you make and how they impact the sustainability of your clubs. Finally, you can take the approach that we did and tackle the big offenders first. As I mentioned today, we've only really been looking at a few specific materials that we've been trying to find alternatives for. Once you tackle the big offenders, you'll see a huge change in the impact of your equipment, and then you can start to tackle all of the other areas to create overall a really significant change. That is it today for me. Thank you very much for listening, guys. I think we're going to open up now to some questions. I'm just going to stop sharing my screen.
Yeah, thanks, Ollie. That was great. Great to hear more about your efforts from your side and your EQ4 board. It sounds really interesting. As Ollie mentioned, if you guys have any questions, please feel free to turn your mic on. Hopefully you can all access it. If not, we've got the chat and Q&A function as well. Etienne, go for it. Feel free to turn your mic on and ask a question.
Hello. Yeah, thank you very, very much. It was really, really interesting. And just so that you understand, so I'm a canoeist, a slalom canoeist by background, and an Olympic champion in that. But nowadays, I'm a windsurfer. I really love windsurfing. So I'm really interested in this and how some of your technology and thinking could be transferred across into the International Canoe Federation and some of the manufacturers that are commonly used. But the question, so I'd like to maybe get hold of your email or something and try and figure out how we could do that. But the thing I'm really interested in is it's different in my sport, because it seems like you have this category in the Olympics, which is essentially set up, and you've got great potential to just, well, am I incorrect to say perhaps for the 2028 games, you could say everyone is using these EQ boards rather than the old school technology, because it would be in the regulations essentially, and you'd have to get feedback to increase the quality and make it feel good. But still, at the end of the day, you could say, they could say this is the board we're using for Olympics. Get into it, get over it, start to use it. Is that a possibility, or is that something that is actually not really possible?
So to my understanding, the regulation, this sort of spec for the IQ foil is set for the 2028 Olympics. And that's in order to ensure, I think, among other things, financial sustainability for the athletes. They've invested in their equipment for the future, and so we don't want to change that. But what we do know is that World Sailing, as well as a lot of other international federations, are looking to introduce rules for a lot of the class-based sports to have minimum content for recycled content in the materials used in the construction of the equipment, as well as having specific life cycle analysis data for those, so that they can compare the environmental impact of that. So it's not necessarily something we can implement for the 2028 Olympics, but what we can do is start working towards future classes, both in windsurfing and in other class-based sports. It's not a sport where we're comparing the equipment. The idea of a class is to only compare the performance of the athlete. And so being able to have a standardized sort of equipment is where we can maybe use a slightly heavier board or equipment in order to push the sustainability of these sports. To speak to sharing information, your point, feel free to get in touch. I'm sure we can share an email address or something in the chat. But one of the ways that we are trying to disseminate this information is through organizations that can share and disseminate information. So one of which is the Sustainable Marine Alliance. That's run by Kelly Covington, which is a group of boat builders, equipment manufacturers, all in the marine industry that are trying to improve the environmental impact of what they are producing. And we're trying to build a sort of information sharing hub there in order to make sure everyone can benefit. and also push innovation further. We have limited resources, as does everyone else, but if we try and target what we're doing and then share that information, other people can learn from it and move quicker.
Yeah, exactly. Just to jump in on that, just to provide some context from board sailing side of things, we do have requirements for bids for 2032. So the class bids for Brisbane Games that will potentially have requirements around percentage of recycled materials and the likes of that, as Ollie was mentioning earlier. Cool.
We have a chat.
Yeah.
The EQ4 built a 91 wide flax balsa board. So the old flax balsa construction is similar. It was another attempt to try and improve the impact of the board. It uses a slightly different wood. The balsa wood is used in a slightly different way. We actually found that, speaking to some of the points I raised today, the workability of the balsa wasn't great because the different densities, natural inconsistencies in the wood meant that at scale it was really difficult to get the same quality board. It actually meant that we were wasting a lot of the boards when we get to a certain point in the process, and we realized that we had sanded through too much of the balsa where it was a slightly different density, and so we were wasting a ton of materials as a result. But a really good learning for us. And there are a few other things. We don't use so much flax material anymore. That's another alternative to carbon fiber, but doesn't quite perform as well as the basalt fiber that we've been using more recently. Sorry?
Great. And Henrietta has their hand up as well, so feel free to turn your mic on.
We can't quite hear you, Henrietta.
Oh, I can't hear you. I'm not sure why, but.
Can I hang on?
Oh yeah, that's better.
It's about, yeah, it's my headset for some reason. It's just being dumb. I'm an athlete. I compete. I'm a para athlete, and I compete in the RS Venture Connect class. And I was thinking in the lines of, because you said something about athlete sustainability, the amount of money that one puts into the competing that one does. I had two questions. I know that the RS Venture class, because of the cost of each boat, they have gone into this style of raising that is, it's what's the word again? They call it like round robin, where the boats are supplied, and it's like the sailing. Sure, the words just escape me just now. They do it with the J70s as well. So basically, it's like a set of materials that are supplied when you come to race. So that was the one question, if whether the EQ foil part of it, whether you could do like a subclass where everybody's competing on the same boards, and you maybe have produced like, say, 20 boards, and then you do a round robin system with the IQ foils. And then the other question that I had is also related to how to make it more sustainable in terms of athletes and what they put into it, by adopting the same kind of system that I know that at least Norway and Sweden and also Germany have done with bottle recycling. That you probably wouldn't be able to add on, or you could technically add on like a recyclable fee. I know they call it pumped in the Scandinavian countries, and I forget the translation in English. But it's basically for every bottle or can that you buy, they have this little mark on the bottle. So you pay 2 crowns extra, and then you get that money back when you return it. So basically you could maybe, I was wondering if you'd thought about maybe adopting it so that if you have a board, an IQ foil, you could get a reduction by returning it to you if you were interested in procuring an EQ board.
Yeah,
Those
definitely. I'll sort of speak to each separately. So the first point on having sort of class boards that are shared, I think it's a great opportunity on the sort of logistics of competition design, should we say, especially if you're running an event that has heats. I know that there's a significant number of athletes in a lot of these competitions, and sharing of equipment can sometimes be a hot topic between athletes. So as the sort of manufacturer, that wouldn't necessarily be something that we have control over, but it's definitely a really good point to bring up with, I think, World Sailing and IQ Class as they're looking for future bids to see how a manufacturer or a class designer would try and approach that in terms of class design. I know that the IQ4 class was actually designed, the equipment was designed in order to maximize the cross compatibility of the individual parts between the youth, junior, adult, men's and women's classes. So certain elements of the setup, the foil, front wing, the mast, the board, the boom, and the sail are actually sort of cross compatible across those different areas, which means that if someone is moving up, they don't have to buy a completely brand new set as they move from junior to men's or sort of youth to junior. And additionally, it means that youth and junior or men's and women's can buy from older athletes their old kit they're able to use in different classes as well. So I think looking at the same way, there's some really innovative ways of trying to approach that to try and minimize the total that you're producing by sharing it between athletes. To speak to your second point on take-back schemes, I think they're awesome. It's definitely a really good solution for looking at how we can better fix the logistics. We still run into the problem of having boards in over 90 countries. And so the consideration is not just a financial one, it's also transporting that equipment to a central location to process it. Realistically, we don't have enough IQ4 boards in one country, even if they're all in one place, to be able to process them there. It's not going to be commercially or probably environmentally viable. But if we are able to bring them somewhere centrally, for example, at an event, that's somewhere that athletes are already traveling to. You can just bring another bag or slot, a broken boom or whatever it may be into their bag already, and then we can collect it there. And that's something we've done previously with previous broken masts, working with some recycling partners. And it's a really good solution, but it requires having the full cycle put together, which at the moment is a really complicated thing to put together.
Thank you.
Great. Ollie, I think we've got something in the Q&A at the top as well. We've got a couple of things actually.
Q&A at the top. Yes, I can see it now. Are there some projects to improve the durability of the sails? Yeah, so the sails are produced by Severn, so it's slightly separate to Starboard. We only manufacture the IQ4 boards, so I can't quite speak to that. I don't know if there's anyone else in the chat that's able to. And allowing to sail on the IQ and putting board. Yeah, great. Felix in the Q&A on changing the class to allow for the EQ boards and adding weights. A great idea. It would be something to bring up with the class, and I'm sure if there is significant interest from the industry, it's something they would consider. There are a few other things to consider on that in terms of the flex performance and feel of the board. There might be a consideration for an athlete that feels they have an advantage from using different equipment, which is obviously with a class structure not what you want. But yeah, it's a really good idea to try and allow athletes to actively attempt to reduce their own impact from their equipment purchases. For anyone that does want to get in contact, I think Lizzie has just put a message in the chat with my email, so feel free to reach out to me.
Cool. Yeah, I will also be sending around the recording of this and Ollie's email as well. So please do get in touch with him if you're interested in learning more about Starboard and what they're doing. Any other questions for Ollie or the team? Okay. One last thing from me. We just have a real quick Microsoft Forms, if you wouldn't all mind scanning the QR code and completing it. It will take you 2 minutes, less than that. And it's really useful so we can improve these sessions in the future and understand what topics you want to see, things you like, things you didn't. So everyone please scan that real quick. But all that's left to say from my side is a massive thank you to Ollie, Lizzie and Pip at Starboard for coming together and doing the session. I think it was really useful and I learned a lot about your work and your work around materials as well. So thank you so much. And as I mentioned, all these details will be sent around when the recording will be up on YouTube as well soon.